it is my honor to welcome my friend and colleague, Dr. Padhraic Smyth, to the stage. He's the Hasso Plattner Professor of Machine Learning, and I have sort of, the first event we ever hosted at the center was one on, believe it or not, on analytics. And Padhraic was gracious enough when we were literally getting started, nobody knew who would even show up to an event or not, who came and spoke about machine learning. This must have been 2013, believe it or not. We had to introduce the whole concept to the audience, and Padhraic just looks at me. I'll never forget this. He said, "It's just statistics." But it sort of is. So welcome, Padhraic.
Thank you.
Great to see you, and thank you for making the time to do this. So why don't you tell them a little bit about your career, and then we'll get started with the questions. How long have you been at UCI? And
maybe one thing worth mentioning, we've heard a lot of exciting stuff this morning. People have been working on AI since the 1950s. Not me personally, but I started in the 1980s working on machine learning, which is the key technology behind all of this new AI stuff. I did my PhD. I'm originally from Ireland. Did my PhD. Worked at JPL up in Pasadena for a number of years, and then joined UCI in 1996. And actually, UCI was very well known for its expertise in machine learning at that time. But machine learning and AI was this fringe topic up until about 10 years ago in computer science, in academia. It didn't work. It sort of worked. Machine learning worked, predictive modeling somewhat. And then about 10 years ago, deep learning came along, and my colleague Pierre Baldi, who's here, was telling me this deep learning stuff is really, really important. And deep learning is the neural networks that are powering LLMs and generative image models and all of that. So that started to emerge, interestingly, not so much in academia, but often on the commercial side about 10 years ago, and has transformed academic research and a lot of business since. So
the one thing I want to highlight, how many of you remember the Netflix competition where they asked people if they could beat the Netflix recommendations? Was it by 10%? And here's the designer of that competition, also the judge of the competition. He told me this fantastic story, which is they were terrified at Netflix as to whether somebody would crack the code and some smart undergraduates would beat the predictions in a week. And it turned out that no one really beat the predictions for over
3 years.
3 years. Yeah. And ultimately, the top 2 or 3 teams got together, combined their solutions. And as we often learn in forecasting, a combination of 3 forecasts is better than 1. And so a lot of this work started at UCI, and that's why I'm so delighted and honored that Padhraic is here. But let's start with the basics. So there's a lot of buzz around generative AI. Yes, last night we featured a speaker from Turing, which helps all the frontier models train on specialized domains. But a lot of the economic value is still coming from traditional predictive modeling, deep learning, but in specific domains. They're not trying to be all things to all people. What's your sense of what's working with traditional AI, and how do you compare that to what's going on with generative AI?
Yeah, interesting question. And I should preface this by saying I'm an academic. I do research in machine learning and AI. So everything I say for the next 15 or 20 minutes, take with a big grain of salt. I don't understand business. If I did, I probably wouldn't be a professor. But as you refer to traditional AI, let's say that's before deep learning, generative models, LLMs, more standard machine learning stuff, predictive analytics, and then the more modern stuff. If you look at, if I talk to my former students and colleagues at companies that run big search engines or popular, companies like Amazon and so forth for consumer products, and a lot of their core business still runs on predictive analytics, optimization. Those technologies haven't gone away. They're still critically important. Now, the deep learning stuff, what it really has accelerated is our ability to take advantage of unstructured data, speech, text, images. You've heard about some of that. It really allows us, instead of looking just at tabular data, brings all of that data into the mix, and we can use that in the predictive analytics and the optimization. But I think we're still, and this is why we've heard this morning, the question of return on investment for AI is still up in the air. Where exactly is it going to work? Where is it going to be useful? Obviously, there's some clear applications, but it's not for everything. And I think the media tends to hype I'll just mention some company names, Google, Microsoft, et cetera, AI for everything. But if you actually look at where they're using AI, they're pretty careful about where they use it. And they're not using it in all their products. And they're making billions and billions with more traditional, technologies that AI can then help and accelerate. But
so, what are some of the best use cases in these traditional use cases? What is AI particularly good at?
Assessing risk, whether risk is financial for banks and loans, insurance companies, medical risk. That would be one example where, yes, an LLM, a multimodal foundation model can take in images and help build maybe a better risk model, but the fundamentals are still mathematical, statistical. At the end of the day, you have to measure, you have to quantify. That stuff hasn't gone away. And I think, I just want to caution business leaders, and again, be careful in taking my advice, but you still need somebody in the room who understands fundamental statistical thinking, evaluation, A/B testing. AI is not going to magically solve all of that. You still have to measure and quantify the benefit.
And that theme came up earlier today as well, which is you almost need a different kind of employee who sort of understands, I never know what the right phrase for this, but data-driven sort of thinking and analysis, because it does lend itself to, a couple of years ago, we had the guy who built autonomous cars for Rivian, built autonomy systems for Rivian. And one of the funny stories he told was the PhD in chemistry with some expertise in machine learning applied for a job, and he was very reluctant to hire him, thinking like, what is a PhD in organic chemistry going to do at a car company? It turned out he went on to become his best employee, because he understood, because that's what he had done his whole life, was design experiments in organic chemistry. So there are these generic, it's not a good word, but more conceptual skills that are useful in the world of machine learning.
Yeah, I think having quantitative skills is critically important. And we face a problem at the universities and also at K-12 in how to train the next generation. With AI, there is a real danger. People talk about existential risk, but I view education as one of the big risks going forward. All of us here grew up in an era where, many of us pre-internet, where you just had to get pencil and paper out and think your way through a problem. Now with language models to help, students who certainly use them, they can have fantastic tools. But if students don't go through that experience of learning how to solve problems, first principles, are we going to end up with a generation, and you will find it hard to find qualified people for your companies? I can see it already, and you talk to teachers at the K-12 level, and we see it at the university, sort of outsourcing learning to ChatGPT. That's a risk, and I think businesses should be concerned about this and keeping an eye on what's going on, K-12 and the universities.
Yeah, I wasn't planning to talk about this, but we see this in our classes every day, because you think they're turning in. Our model was you turn in a good homework, you get graded well, and you've understood the material. And now we're learning that for some students, it doesn't indicate anything of this sort, because they've used LLMs and, as Padhraic said, outsourced the learning. But let's get back to the subject. So this is, I think your point's well taken, which is it's incumbent on all of us, with our children, with us as professors, with you as hiring people. You really have to start paying attention to the kinds of people you're hiring, and so on. But getting back to AI, these large language models are all the rage. And they all, last night we were talking about how the scaling laws hold up. His name was also Vijay. His position was he thinks scaling laws are hitting their limits around training, which is there's only so much you can do with more data, more parameters, more servers. And at some point, the training data needs to get better, which is they're using sort of experts, reinforcement learning with sort of human feedback and so on. They have this concept of reinforcement learning gyms in specific domains. What is your view of where we are in the progress of these foundation models and large language models?
Yeah, another good question. And I'll, again, preface my answer with the caveat that researchers, especially in academia, have a very poor track record of predicting where AI is going. But it does seem like we have kind of run out of data. It's like for large language models. And OpenAI was saying this about 2 years ago. And now there is a feedback loop of, the LLMs are crawling the internet, and a lot of the text they're grabbing is LLM generated, and that is not good. So the one thing to keep in mind is all of these AI models are built on data. They're built on machine learning. So they're trained on training data sets, and they're sort of only as good as what's in that data. We can try to extract more out of them in terms of reasoning on the fly and get them to be a little bit more structured. So I think the scaling, just as an academic, I agree. I think it's likely that it's running into limits. That would make sense. And then the emphasis becomes, okay, well, with these black boxes that we have, how can we get them to be better, to be more reliable, to have more appropriate confidence in their output, to do more careful reasoning, that kind of thing. And I can see that in the academic research side. There's more emphasis on that now. And let OpenAI spend billions of dollars and burn down the planet, building data centers if they want to.
No, it's interesting that you said that, because the gentleman also said that we should all focus on average useful intelligence rather than worry about, artificial useful intelligence rather than artificial general intelligence or artificial super intelligence. I'm curious, in academia, when you see all of this marketing around, we're racing towards artificial super intelligence. Is that of interest in academia, or is that just not what we focus on, or what you guys, Pierre and you and the other superstars we've got here?
Well, obviously, it's as a human being, it's something you think about. With individual research projects and students, it's not on a day-to-day thing that we think about. We do look, in my own research group, we look at bias, we look at reliability, we look at confidence of these models. A lot of our own research is on how, given that these models exist and they're built by large companies and so forth, if you put them in a workflow, how are they going to interact with humans? So what's a human AI workflow? I think there's very interesting questions there. Like if you have a sequence of tasks, let's take radiology as an example, but it could be loan applications, whatever. Tasks are coming in. How do you delegate to the AI, to the human, and still have the human have some agency and somehow oversight? So effectively using maybe the skills of both the human and the AI. And there's a lot of interesting research to do there. But I've kind of ducked your question. Personally, I do think the risk to things like education or misuse of AI in a medical setting are greater than robots walking in the door, in the next few years. But I don't really know. So yeah.
And then sort of one of the things that we talked about was also, these companies are quick to talk about how well they do on benchmark tests. So yesterday, was it the day before, Anthropic said they're the best in the world at coding, for example. But one of the things that we worry about is those are not real world benchmarks in some cases. Maybe the ones in coding are a little more real world than others. But there's some amount of teaching to the test that goes on in this, right? So these models are hacked, if we can use that phrase. You know much more about this than most of the people in this room, so what do you see?
Yeah, I think the concept is fairly simple. I mentioned machine learning earlier, and really machine learning itself is built on statistics. So think of just fitting a straight line to noisy data, X and Y, but take that up to millions of dimensions, but it's similar concepts. And so you're fitting to data. And so the model is trained to try to optimize on the data. When you fit a large language model to text, it's trying to literally predict the next word as best it can on billions and billions of words. So inevitably, it's going to do better on the data, historical data it's seen, than on any new data. So this is analogous to a student that works very hard and reads a lot of the class material and studies the past tests. They can do really well sort of on the stuff that they've seen and memorize it. But the really good student can go to new problems and generalize. And LLMs don't do so well on that. So companies like Anthropic will, there's a lot of hype, and they will take the benchmarks that academics have put out and say, hey, look, we did fantastic. But they've been, in the past, and I don't know if the recent results are true, it was shown that, in fact, sometimes they don't even know were those benchmarks in their training set. So sometimes they can't even tell because of the way the data is collected. So I would take with a very big grain of salt statements by companies, and you take any of the big companies that are pushing AI, that their model can code really well, that it can solve medical problems really well. There's usually overconfidence or exaggeration going on.
And Nicole already pointed out today that some of the coding really well doesn't include things like how secure is the code, right?
Absolutely.
That's not part of the benchmark for sure.
I mean, in coding, I had dinner with a former Google, with a Google student, a student that now works at Google the other night that was in my group, and we're talking about it. And if you're already an expert, you can evaluate the LLM generated code and see where the flaws are, and you know enough. But if you're a novice, how do you can't do that. So that's, experts can use, say, LLM generated code or LLM generated output because they understand the context, they understand where the weaknesses may be, but novice engineers, not so much.
And we saw that in research that we have going on at the center, where we saw that junior software development engineers get higher gains in productivity because they're able to generate more code, but it doesn't capture some of these less tangible effects that...
I mean, everybody can generate code in this room, but testing the code, making sure it actually works, that's the hard part. And who's going to do that? And having LLMs test themselves, which people are looking at, is an interesting way to go. But there's going to be some really interesting issues. And again, the human AI aspect, who's in charge of what, where does the human come into the loop? I think is going to be very interesting over the next several years.
And so, sort of there's this huge rush towards AI, and you're seeing more and more, this is our world, in the business school side of things, we see AI in more and more use cases in organizations, and it's growing by leaps and bounds. But we've also agreed that these systems are black boxes. They're not very explainable. So we don't always know what they can and cannot do reliably. And I know some of the research you do is focused on testing of these models and so on. How should executives who are deploying AI think about the predictability of what these models do, and sort of what are their limits? Like, how do you even conceptualize this in a way that you can make decisions around?
It's hard. Build prototypes, have clear metrics about what is successful or not. Having a way to measure the accuracy, reliability of these models. So having test suites, you have to think about how are we going to evaluate a model? Just testing an LLM, there's so many, the combinatorial number of possible outputs it can produce given inputs. Are there potential legal risks, brand, sort of reputation risks if you're dealing with consumers? So I would say prototype, do A/B testing, be quantitative. AI is not magic. It's a useful tool, as was said this morning, and it'll solve some problems. It'll be fantastic. But there'll be other problems where traditional techniques are probably better and cheaper. Because the other thing I want to mention there is that to take an AI, like an LLM from a company, and then to adapt it to your problem, that could take millions of dollars to do that, and you have to factor that cost in. So these are very general purpose tools, but your problem for your business, it might not be the best solution. It might work if you can afford to hire some really smart people for 6 months and tune it and adapt it and retune it and retrain it, but that might not make sense economically. So I think you have to look at what are the good, I think the businesses that will succeed will be the ones that figure out AI is good for this problem, but not for that one. We shouldn't use it over there. And don't be swept up and you have to use AI for everything, because I don't think that's...
So in terms of some sort of generative AI technology roadmap, do you see breakthroughs on the horizon to this, new architectures, this hybrid models that we're seeing neurosymbolic AI combining neural networks with symbolic reasoning, which is the old traditional logical reasoning, with mixture of efforts. In your world of you're paying attention to the latest research done anywhere in the world. What are you seeing that sort of says, oh, this would be really good if we actually pull this off?
Well, again, academics often don't recognize the technology that they're developing. So I would say maybe the last big breakthrough in generative AI was the transformer model, which is behind LLMs and all the other big models. That was a huge technical breakthrough. It wasn't recognized at the time by it was like we were like, oh, that's an interesting paper. I wonder what that's useful for. And so I think right now we've maybe flattened a little bit. I don't think there is anything, but there could be something lurking that's transformative, to use a pun there, but can really change things. I do think that in academic research, we're thinking about these LLMs as an example, as a black box that's a component in an overall system design. And how do we build a system around it? In traditional engineering, computer science, how do you build a system, design it, test it, field it, update it, and treating the AI as a component in a bigger system that, what are the principles we should be teaching students about evaluation, testing, and so forth. So that's a little bit more boring and pragmatic, but actually really important.
I think that's very well said, because we always talk about humans in the loop, and that's sort of but the broader picture is, at the end of the day, AI is going to go into these fairly large, complex, sophisticated processes in organizations, and sort of how they fit in the overall scheme of things, and figuring out like what you can trust the AI to do, and then what should you do with the results that come out of the system, I think. So final piece of advice, like one of the things I'm taking away is, it's like, yes, there is a lot of energy, there's a lot of power, but it's almost like we're in a construction zone, and they always tell you slow down before you can start hitting 65 again. Is that sort of where we are, which is proceed with caution?
Well, I'm a cautious person, so you probably shouldn't listen to me. Repeating what was said this morning, AI is a phenomenally powerful tool. is it useful for your business? And that's the question you should ask. And there's a lot of hype out there, a lot of vested interests saying, yes, yes, you should use it. Think about it, evaluate it, do a prototype. So I think, yes, it will be extremely useful, but we're still figuring it out, what it's really.
Yeah, and we've, in many off-the-record conversations that we hear too, is like, look, you have to attract major venture capital dollars to support your business. And so people say these things. And in the old days, we call it vaporware. This is sort of a new generation of promises, I guess. And, we'll see what comes of all of it. But Padhraic, thank you so much for sharing sort of really research-based insights on where we are in the world of AI. And caution is good, I think, in a world of AI. It will make us all, in the long run, a little bit more resilient, I hope, as a society. So thank you.
Thanks.
Appreciate your time with us. Thanks.